Let Chuck have it, and if you have some questions, I can talk to you then later on.
Okay, well, a lot of the information that is real specific and technical is detailed out in the handout that I gave you. What I'm going to do is point out and kind of touch on some of the equipment that we use in the telephone system, some of the concepts, and then at the end of my presentation, everybody will have a chance to mill around the room. Aaron will be over next to the trunking equipment to talk about T1s. Steve will be available if you have questions about some of the copper. And then I'll be available to answer any questions about any of the telephone infrastructure equipment that I'm going to talk about. The telephone system on campus is an Avaya Aura Communications Manager. It's a version 5. And it consists of 3 primary servers that handle all of the call processing. 2 of the servers are called an S8800, and that's these 2 servers right here. I'll apologize, when we installed the equipment years ago, we never thought about facing it this way so that everybody could see the fronts of the servers on a tour like this. So you get the back end at the moment. But it's kind of cool because it shows you some of the connections. These 2 servers handle all the call processing on campus. Anytime someone dials an extension number, this is the system that tells it where to go to. Anytime somebody dials a number off campus or a number comes into campus, one of these servers tells the system what to do with it. These servers run in an active passive or an active standby arrangement so that if the active one fails or has a problem, then the second one immediately takes over. Calls aren't dropped. It's it's completely transparent to the end user. Now, you notice I said that we had 3 servers controlling call processing. The 3rd server is called an ESS, or an Enterprise Survivable Server, and that is actually located in Burkhardt. And its purpose is if both of these fail, then it immediately takes over and handles all call processing. It used to be years ago that if something happened to this room, all communications on campus were gone. We've updated that so that now we have basically a 3rd brain available so that if there is a problem in this room, we have a system that will take over. And I will tell you this from experience, that it is transparent and you don't know it because we've come into work and that system, there's been a hiccup, that system took over, and nobody on campus was any the wiser. Now the next item that we have are these great big gray cabinets that you see here. These are called MCCs, or multi-carrier cabinets. Basically, they are the legacy portion of the phone system. Anything that is connected to the phone system, an analog phone that you see there in front of the white phone, a digital phone, T1s, anything that is operating off of the phone system corresponds to a card that is plugged into these cabinets. We have 19 of these cabinets in the system in total, spread out amongst 11 different switch rooms on campus. Each of those cabinets has what's called an IPSI card, or an IP Services Interface card. Basically what that card does is that connects that cabinet to an IP network that these are connected to, and that IP network is separate from the campus network. Now you're probably asking, well, why is it separate from the campus network? Well, before the introduction of unified communications, the networking and the phone groups were in 2 completely separate areas. Networking was IT, telephone services was business affairs. We weren't together, we didn't work together, and so we had our own network that basically just has the connections for these 2 servers and all those cabinets put in place because it's something that we had control over at that time. Were we to do this today, we wouldn't do that. We would have it all connected to the campus network. So basically, Each one of those cabinets is connected to this private network, and Avaya terms that an IP Connect network. Basically, if the system needs to send a call from one cabinet to a phone that resides in another cabinet on campus, the connection from cabinet to cabinet is voice over IP. Anytime you go to the outside world, you go from voice over IP from that cabinet to the cabinet that has the PRI or the T1 connection in it that takes you to the outside world. Each one of those cabinets has dual IPSI cards in it. So that way, if one IPSI card goes down, that cabinet stays operational. If you only had one and that IPSI card went out of service, then every telephone that exists in that cabinet would be dead and unavailable to any other telephone on campus. And you'll actually see each of these connections are connections to that IP Connect network. And each one of these servers also have dual connections to it. Again, we tried to be as redundant as possible, as we could throughout the deployment of that. As far as phone service itself, there's 3 different types of phone service that we offer. Analog is just the basic telephone. It's like what you have at home. It's a single line, which means one number rings that one phone. It's used for residence halls. It's used for fax machines, security phones. It's also used for like faculty offices where they don't need to have anything special. It's just a standard telephone set. We have digital, which is represented by the white phone, and it is multi-button, multi-feature service. I can have more than one telephone number ring at that white telephone. I can have specialty feature buttons programmed onto that telephone. That telephone offers me caller ID so that I can see the number of the call coming in. And then we also have voice over IP service, which I know is the one thing everybody's interested in. And that's represented by the 2 phones right next to that. The phone to the immediate right of that white phone is an Avaya business voice over IP phone, and it uses H.323 signaling. And basically, what it does is it gives you the same feature functionality as the white phone. You can have multiple lines, you can have feature buttons. Those interact through a series of cards that are in the system. One's called a control LAN card, the other is a MedPro card. A control LAN simply does the registration of the phone, so when the phone starts up, it logs into the phone system as an available entity. The control LAN card also handles the setup and the tear down of the call, so when you go off hook, that's the card that serves as the interface to the telephone system so that you can enter your digits and tell the telephone system what you're wanting to do. There's a second card called a media processor or a MedPro, and that actually handles the audio stream between the telephone and the phone system. The Avaya 9611G or the multi-button voice over IP phone, again, those use H.323 signaling. The phone next to it is a Polycom IP331, and it's a SIP phone. And basically, it is what we use as a replacement for the analog service. It's a single line phone, but it is a substantial upgrade because it does give you, built-in conference keys, transfer keys. You get caller ID at that display station. The biggest difference between that and the H.323 is there is a separate SIP enablement services server or SES server that controls the setup and the tear down of the calls and the registration. But no matter what signaling you're using, the media processor card always handles the audio stream between the phone and the telephone system. Now, the CLAN, the MedPro, and the SIP server, those are all connected to the campus network. So what does that mean? Well, if I use an analog or a digital phone, I have to make a physical wired connection through copper from the jack in my office to a port off of one of these cabinets. These cabinets are situated all around campus, and they serve, for example, the Burkhart building has 4 of those cabinets in the basement of it, And those cabinets are all have wiring from Burkhart to the different buildings in the quad over there. So if I need an analog or digital phone to work, I have to actually run cross connects from cable that originates in Burkhart, from Burkhart to, say, the ad building, which would be outside service plan or OSP cable, into the basement of the ad building, and then I have to use riser cable to get that connection going from the basement to the jack that resides on first, second, or third floors. The voice over IP phones, they plug into the same data network that you plug your computer into. They don't need a physical connection back to the phone system. That's what the CLAN and MedPro do. So it gives you a lot more flexibility when you're dealing with voice over IP service. And you will actually see an example of each one of those phones over there. The black interface that's laying on the table, the voice over IP phones need power to work. That power can be done one of two ways. You can either use a port injector, which is basically just a power supply you plug into the outlet. Your data cable goes into one plug, and then a plug from the power injector to your phone helps transfer the power to your telephone. Or what we're using on campus is PoE or power over Ethernet, where the power for that phone is actually supplied from the network closet. So what we've tried to do as a deployment rule is, if a building is being renovated, then that's the opportunity we're taking to upgrade their service to voice over IP. It gives us an opportunity to make sure that the data equipment is offers PoE, and it also makes sure that we can have the necessary generator power backup for that data closet. Because since the voice over IP phones get their power off of the data switch, if the power to the building goes out, you got to make sure that data equipment stays up, because if not, then your phones go out. So right now